Hi everybody. I'm going to talk today about Rudder language. As you may know, there's no such thing currently, so we're going to create a new language. So the first question you may ask is why? So why? There are many reasons. One of the first one is we currently support CfgMgm as an engine. And we also support DSC as an engine for Windows. So we currently have two languages to target. But we may want to have other ones. For example, we may like to have MGMT because it's very reactive, very fast, and it can have features that we like. We may want to target Puppet because there's a big install base. And so people may like to interact with the existing Puppet code. We could target Ansible because Ansible has a different model, and you just need to have keys to your machines to manage your machines. So you don't need to install a new agent if there's already one. So here, it will be easier to target many different agents if we have a language. Another reason is that currently we don't we target CfgMgm or DSC, but you don't write DSC code or you don't write CfgMgm code. You write NCF code. NCF is library. NCF is a library. It's the library we use to transform the concept we have in Rudder, for example, the techniques, generic methods, into the real code of the agent, namely CfgMgm and DSC currently. But we need some code to this library maps our concept to those agents' concept. So we have a mapping and we have to write a lot of code. And we could put this code into a generator. One of the reasons of this is that, for example, if we need a new feature, we have many generic methods in NCF. So if you want to add a new feature, we have to implement this feature for each generic method we have. So we have around 60 methods currently. And if we want to change logging, we have to change it in 60 different files and 60 different methods. So if we had something to generate this code, we would just have to change it in one place, and the new feature would be implemented. So here's what it looks like. Currently, we implement all those features, the 4 features, logging, having a report, having a different audit mode, etc., and many methods, and each time we have to implement everything. If we had a compiler, we just had to implement methods in this language, so our 60 methods and tens of features, and that's all. Another advantage of a new language is that we could have a higher level language. So this is a target. I don't say that it will be high level. At first, it will be just the same as we have currently, but it will be easier to change the language to make it more descriptive, as we all want, be less prescriptive, meaning that we leave the logic part to the compiler and to the agent as much as possible, and so be more expressive. This means that if we want to have less code, we can just add a new, I don't know, it depends on the feature, but we can add new keywords, new syntax, new things in the language to make it easier to write and to make it less verbose to write. So one of our goals with this language is to have a compiler. So because not just something that interprets the language, but something that transforms the language from this code into something else. The advantage of having a compiler is that we can be more strict than existing language, and we can have compile time errors. That is very important because it reduces the feedback loop. And we can have higher level checks, so we can check for things that couldn't be checked currently, because this is just currently we just have things that are laid down one after another one. But we could have, if we have more high-level concepts, we could check that those concepts are correctly written. And we could have type checking, also something that can be done at compile time. So you can have error before they goes to the agents, and you can have them directly on the server. So it looks like this currently. You write code, and then you have to wait until this code is on the agent to know if it's correct or not. If we had the compiler, we could write code, compile it, check if it's correct or not, and have much more errors fixed before they go to the agents. So this reduces the feedback loop. I know I'm not the best in writing schemas. So another question is, why not use an existing language? Because there are currently many agents, and many of them define their own language. The first one is none of them have a compile time warnings. They all interpret their code. So we can be more strict and have this feedback loop. We can separate the compiler and the interpreter and have this advantage. We can also add things to the language for ourselves, which means that if we depend on another language, we depend on their interpreter, we depend on on if they want to add something or not. And if we want to have a specific feature, we can add it by ourselves if we write the language. And one of the things is that we won't depend on the different things you have on an agent, the things that you have to do or you have to write if you want to make sure it works exactly like you want, because it is not supported, not something that they want to have. So we have to work around, and those workarounds would be implemented in a compiler and with a compiler. So it would be easier for us to support many different agents. And yes, it will be a new domain-specific language, and I think it's a better thing than just have a data format. And something that I added after yesterday's talk is that I think everyone should have his own DSL, just that you shouldn't publish it always, because sometimes it's just for you, and you solve your own problems with the DSL. And since it's your own problems, it's not always a good idea to share this DSL with everyone. Well, it is not for everyone, it's for you, because it solves your problem. So next we'll talk about how we will implement this new language. The first answer is that we have to define the language, of course, and there are many things to define that are that we started currently, but that is not finished. So first we have to decide what concept we want to show to have in the language, and then the syntax we want in this language. Each time we decide something because of the implementation or because we want this, or for any decision, we want to write a design document to say why we chose this. And then the last thing that we should not forget is that we would like to be as transparent as possible for our users. So we want to not only write a compiler, but also write something that can translate existing code, whatever the language, into our new language. Since we want some higher level language, there are some concepts that we won't be able to translate, and then we will either have heuristics to guess it or ask the user to provide more information. So I'll show you some concept later. About the syntax, we'll try to be as close as possible to existing languages to not be surprising to users. We won't use semicolon. And so yes, we'll try to be easy to read and to look like an existing language, even if it's not really an existing language. Yeah, so let's continue. So for the compiler, the first step after having knowing the syntax is to build the compiler, to write it, and we chose to write it in Rust. Why Rust? Because it's an interesting language. It prevents us from doing a lot of mistakes because there are many more compile time checks than in many other languages. And since that's a property we want to have also in our language, it helps us know how to do this. And next we chose num for parsing. I don't know if you know num, but I'll explain you just a little bit after this how it works because it's very interesting. So the idea is that we just pass the code, put it in a data structure in memory, have all our checks, many checks, check for sanity, checks that things converge, check that types are respected. And then when this is done, we can generate for target language. And then we can have many generators to choose the language, the engine we want. So currently we are going to target CfgMgm and DSC, and maybe add new targets later. So just a little word about num. Num is a library for parsing written in Rust, and it's based on the parser combinator concept. It makes it easy to write parser. So easy to write your own language or to parse something that exists. It makes it a bit complex to do proper error reporting. So you have to write many code to have a good error reporting. And we want good error reporting because one of the goals is to have short feedback loop, which means that there must be a feedback loop and error reports that are useful for the user. So yes, a parser combinator is something that is a concept where you have many parsers. This is a parser, this is a parser, etc. And you just have to combine parsers between themselves to make a new parser. For example, you have a parser that can parse a separator and one that can parse just a word. So these are small parsers. And you can combine them using an operator that's called here delimited, and where you can write a new parser that can parse a list given a separator and a word. And you can have just a list of words. I don't have to write anything to get the list of words. You just have to call delimited on existing parsers. So just write small parsers and combine them to make more complex parsers. This makes it very easy to write parsers of anything. And num is is used very often in Rust in the Rust world. So next, after having a compiler, because now we know how to transform our Rudder language into the target we want the user to not be aware that we have changed everything in the carpet. So we want to transparently keep existing code, so translate this code into the Rudder language code. So again, we'll use Rust, because we already started using it, and it's a good language, as I said before. So the first thing is we already have something to read our code, and that transforms it into JSON. So just use this JSON output. We don't have to rewrite a new parser for what we have. And convert everything that is obvious, because there are many things that are common into what we have today and what we want, of course, because, well, we already started to push the user to do what, to do things how we wanted them to do. So it can be, it will be, many things will be easy to translate, but something won't be. For example, currently we don't know if you have a condition based on the type of system you have, or based on the result of an generated method. Currently, it's the same thing in NCF. So the goal is to separate those things, and we'll have to, based on heuristics, to guess if it's a system or if it's something else. And if we cannot guess, because it's, I don't know, too complex, etc., we will need to stop converting, accept the code as it is, and we'll wait for the user to fix it to be able to fully translate into the new language. So the goal is to have those, so the translator and the compiler, into the next version of Rudder, and work in parallel with existing the editor, so that we can try to translate and compile existing techniques, and to have logs to see if it works or not. So we'll be able to tell the user next time we want to upgrade Rudder if this will work or not. So we will be able to know if the upgrade will work, and we can tell it to the user. So the goal is to not block the user, to make sure it always works for him. And when we'll be ready, and when the user will be ready, we can translate everything and start from a new repository, a new code base that will be this Rudder language. Yeah. So now let's look at what this language will look like. So first, we won't implement everything, because a language is good, but it can be very big. So we want to target a subset of this language. And the first subset that we can see, and that's easy to implement, is what we currently call techniques. That will stay techniques. So to be incremental and to start small, we will implement only what is needed to implement techniques. So yes, this subset. So there will be nothing very new, because we implement what existed currently. We have a language. We want a language that looks like existing language. We want concepts that have a meaning for users, so that we may take from existing language. So it can be boring. So the first concept is the resource. So the resource represents something in your system. It can represent the system, it can represent a service, it can represent a file, it represents something in the system. And the resource is identified by one or more parameters. And a resource without parameters, a parameter is a resource that only has a single instance on the system. For example, if you say, I don't know, SMTP, and don't have it parameters, it means that you will only have one SMTP instance on the system. This resource, those parameters are identifiers, which means that if you declare two resources with the same parameters, it will mean that you will have the same resource. So you will speak about the same one. So we'll merge the state definition. And if you don't have the same parameters, it means that it's different resource. So you can have different state. The next concept that goes with it is the state. So the goal is to have, as we always wanted in Rudder and in most of the configuration management tools, is to have a desired state. So a target state that you want to have on this resource. This state too has parameters. And so if you have the same state on the same resource, it will be the same thing, so we'll merge them. If you have a different state on the same resource, it means that this is incompatible and you are trying to do something that will flip-flop, that will change all the time. And so we'll refuse it. Yes, just an information, there will be two kind of state. It can be absent, so there will be only one absent resource state, and there can be many present state because there can be many ways to define the state of a resource. So the goal of having this is to be able to detect at compile time if on the agent you are defining things that are compatible or not between them. So here's an example of what it could look like. So this is the declaration of the resource of type file, and that has one parameter, which is the path. So a file is identified by a path, and the state, for example, the content of the file is parametered by a list of bytes, by a string, by anything. And here's the definition. I didn't put it here because this is something that will be implemented within the library, and it's not necessary here. Yeah, so I didn't put this because the content, because we won't implement this now, because as I said, we are targeting just the technique writing. So this will be written in the library, and in the first implementation, it will be our current library as it is. Here's another example. If you want to configure OpenNTP, it's a resource without a parameter, which means that there can be only one OpenNTP on the system, and it can have only one state without parameters. And here is how you say that you want to configure this. As an example, you want this file, the file etc.ntp.conf, to have this content. And this is your configuration, so you can put one or more, as many states as you want in this configuration. So currently, this maps directly to what you have in the technique editor in Rudder. So yes, another goal is that we can easily parse and translate this into something that can be used in the technique editor, so that you can write this directly in the web interface in Rudder. I didn't say this as one of our goals, but it is important for us that it remains easy to write directly in the interface.
But can you also abstract, for example, the file path, so it's not hard-coded? So
yes, well, we can have variables. So the idea is that we can either put the file etc.ntp.conf in a variable. I don't know if it was the question, or?
Yeah, I mean, what if some operating system has a different path, and you lose the same thing that CfgMgm is good, that it knows what path it's supposed to edit.
Oh yes. Well, here you are when you are the writer, you know of the technique, you know where it is supposed to be, because you are writing the technique OpenNTP, so the one who's writing it knows where it should be. And it can be abstracted via variables, as it can be in yes?
Just to understand though, can you apply the same kind of condition logic with this, like a condition for deployment on Debian 7?
Yes.
Because I think that's what he's more asking.
Oh yes, there can be conditions, and you can make a different line for different systems or different, yes. Yeah.
Would there be something like self-bundle over the path?
Self-bundle, which?
You can call back to yourself.
I don't know. Well, I didn't think about it currently because I've not seen the use case yet, but maybe. Yeah. So yes, this is currently just a very contrived example. There's a specific state resource that is the universe, which is your system, the thing you are configuring, and so you don't have to declare it. It is the only one that automatically exists everywhere, even if you're not configuring it. And it has a main state, which will be the entrance point of the language. We also already added the concept of metadata, which is just a bunch of key values that are associated with either a line or a state, a resource, or anything that we have in the language. The main goal of this metadata is to be able to influence how things are generated for a specific target. So let's see an example. Here we currently have this metadata in our techniques, so we can use this information in the technique editor, but it has no use for the target language, for the agent, because it's just information for the user. So we'll store it in metadata. We can also have a specific compiler, specific target metadata. For example, there's the component thing that we use to know how things will be logged into and sent to the server.
Is this then a key value or something JSON parsed thing, or is this just something?
It's key, and the value can be either a list or an object file with JSON notation or a string.
Okay, but this has some technically evaluated value then later somewhere.
Yes, it is. Well, it is. The goal is to make sure that is correctly parsed, but it is not evaluated unless it is evaluated only on specific places. For example, here this is evaluated for. It is not evaluated. It's always evaluated, but it is only read if you are using it for the technique editor.
Okay, so this is.
But it is always validated. And for example, the component will be used. It is always evaluated, but it will be used only if you are targeting CF engine generation. And I said that there will be variables in the code, but there can't be currently variables in metadata. It is a bit complex, so we'll skip that. And this wouldn't compile because there's a missing.
And also you have the UTF-8.
Yes. Double quote. Yes, it's UTF-8. This one. Yeah. So we also have types because, well, as I said, there can be parameters in many places. For example, here or here. So those can be of one of the types that are declared later. So we will have classic types. So a dictionary, array, string, integer, booleans. So things that currently can be expressed within a JSON file. And every parameter, whether for a resource or for a state, are of a given type. And if you don't specify a type, there's an implicit one that is string. So we will check that the type every time you use it. You use a variable. You call something with a parameter. We'll check that the type is right and that you don't mix up those types. Or the default type can be detected because we want to support default values. That's something that we don't really have currently. We'd like to have default values everywhere. And that's the kind of feature that costs us a lot because we have to touch every generic method to support it. So if you have a default value, the type will be guessed from this value. So the type dict is the dictionary, a bit like Python. It's a type we already have currently in our technique editor. It's JSON-like, so you can have key values. Values can be strings, integer, etc. So here is an example of how to have a type declared as a parameter. So you declare the variable name and the type. And if you have a default, this will be a string. This is the same. There will be one integer parameter, then a string parameter. Or you can have this kind of default value. This from here to here is a default value. So default value is a JSON object, JSON-like object. We don't already have a type notation for this kind of things. It can be a bit complex. There's a new thing that we don't have currently. It's the type enum. It's a bit like the enum that exists in C or in Rust, except that it doesn't have any data associated with it. That is the case in Rust. And the idea is that it can be inferred from other enums. And it's, for example, if we have the enum Debian9, we can infer that it is a Debian. This knowledge will be included within the standard library in Rudder. So it's not out of nowhere, it's not from the name, it's really included in the information. So for example, we can decide that if we have success, it is okay, because we have 3 states, that the outcome state from what we run. It can be either error, repair, or success. And repaired and success are okay results. So here's how it looks like, the declaration of a new enum type. So for example, you can declare that an outcome can be one of those. Some enums are global, which means that there's automatically a variable that has the same name, that is global and immutable, that can be one of those values. So if you have an agent based on this, necessarily have an OS variable that is available and that gives you the system on which you are running. And this is how we infer an enum from another one. And for example, an Ubuntu is of a Debian family, and the Debian is of a Debian family. Yeah.
Will you allow it not to be completely JSON compatible, so the last element can also have a comma at the end?
Yes. Yes, it is already done, written, and yes.
The last has to be different.
Yes. So the goal of the enum is to be able to have cases, to write different cases, like you said before, when I want to have a file that is this file on, I don't know, SUSE, and another path in Debian, we'll have cases. Cases are always based on enum or enum expressions. So you don't necessarily have one enum to enumerate different cases. You can write any enum expression. And at compile time, we will check that your expression is at the same time complete and non-overlapping. Complete means that you have all the cases, and non-overlapping means that you don't have the same case twice. And it can be self-evident if you are just using those enum, because you only have Ubuntu and Debian. But it can be more complex if, for example, you say, in one case, I want Debian 9 or Ubuntu 14, and the second case, Debian or CentOS, and you have overlapping, but you didn't see that. So the compiler will check that you have non-overlapping and complete cases. So it will be a Boolean expression based on enums. And so we will need, because otherwise it would be overly complex, we'll need a default case in cases. And it's not a problem as long as it's explicit and you know how to handle default cases. So here's an example. If you want to have 2 different cases, so something that you do on Ubuntu and something you do on Debian. Here, I've put a prefix here because there are, as I showed you here, there are 2 kinds of Debian. There's an OS Debian and there's a family Debian. So we want to make the difference between them and make sure that we are targeting the system Debian and not necessarily the family Debian. So this won't match on Ubuntu, and if I didn't put the prefix, this would match on Ubuntu, because by default it's the family that match. Yes?
Isn't the first one consuming the case and so not doing the Ubuntu on the second?
No, we check that it's not overlapping to make it very explicit that which case is which. Yeah.
Why not just have a prefix family and a prefix OS? Maybe I didn't understand that.
Oh yes, there's a prefix family, but we choose to. It is possible to not specify it.
Oh, okay.
Here there's an implicit family prefix. If yes. And here's another example. Because here we have global variable that matches an OS, that it was a global enum. So there's always a variable that is present to match this. But there are cases where enums are in variables, and there's no global variable in local variables. So you have to specify the variable. So here we are matching the variable outvar with the enum value repaired. And so here is how we define the default value. So by default, we'll do nothing. But we could say that here, well, yes, we have specific things here, like log something, like, yes?
Is there a comma expected at the end of the...
Currently, no, just a new line, but do you think it would be better?
I have no idea, it's just strange.
Yes. Maybe, oh yes, there's one here. So I think currently we just need new line, but I'm not sure. No, no specific rule. Maybe, I don't know. I'll have to check what we implemented. But since it's not completely finished, you can tell your preference. Okay. So we can map this with what we have currently in Rudder. So currently we have generic methods. So it's a state in what I said just before. We have method categories that currently almost match with resources. We have techniques. So a technique is one resource with one state and tied together. We currently have outcomes on generic methods. It will be linked or conditions or classes, or it depends. Okay. And this will map to enums. And the hard classes, which are defined automatically on the agent run, will map into global enum. And for example, report component will match into metadata. So now here's an example of one technique, how it's written in the new Rudder language. So we have a format to make sure that we won't make an error with other kind of things, with next versions. The metadata for the technique. The resource, because I said a technique is a resource plus a state, and the state matching it. So with the component that say, we'll report this as the name package present. It will be, that's the text that will be present on the server that tell you what happened. Yeah.
Do you have a component name that will be changed based on the operating system?
Currently, no. Metadata are independent of what you write inside the technique. No variable, no case, no. So when will it be available? Well, first there will be a first release in 6.1, very soon. But it will be, as I said, it will be a test release. The goal is to be transparent. The user won't be able to use this language to write new techniques, because we will just translate and compile techniques in the technique editor, just to make sure that it works on the techniques we have that exist in Rudder, existing Rudders. If we are confident, we may report compiler errors to the user so that he can prepare for migration for next versions. So we don't know yet. And this can be still changed because this is a small subset. We don't have everything specified. We may have new versions of the language. And there are many other things that can be defined. So when this will be done, for the next version of Rudder, we intend to rewrite NCF into the Rudder lang, so have other concepts into Rudder lang. So let's see quickly how what are those other concepts. Again, that will be concepts that are usual in other configuration tools, so nothing very, very fancy. We just want to separate three notions that are functions, measures, and actions. So the function is like a function in mathematics, so not in every language, which means that it doesn't affect the state of the system. So it cannot read, it cannot write anything, it just computes something. So for a given input, the output of a function doesn't change. A measure is something that reads something from the system. So something that can change, and the thing can change between two measures. And you can combine function and existing measures to measure something else. And an action is something that can modify the system. So you can write something and to make sure that to change the state of the system. And you can combine functions and actions to change the state of the system, and measures too. State, let's come back just once on states. The goal will be for our library to define states and resources. So we'll have to define states from what we just did before, because we are writing the library, so we don't have basic states. So the goal is to not change things that don't need to be changed, that like every configuration language do nowadays, and just update things that need to be updated. So it can be a combination of any other states, and if you use the keyword unsafe, not yet sure, but this name comes from Rust, to allow things that shouldn't be allowed to be done. For example, you should be allowed to use actions to define a state. Because if you have measured that you want to change something, you can change it, but the compiler won't be able to check that you did it correctly. So the unsafe keyword is here to say that you did what you wanted, what exactly you wanted to do, and the check, you did the check, and the compiler cannot do it. So for example, if you do a restart after a file change, well, this is a specific case, but if you want to do an action like restarting a service after a file change, this is something unsafe, because we don't know if you are not changing the system all the time. The restart is specific because it's so frequently happening that we will have a specific check in the language to make sure that you can call restart on some events without having to say that yes, I did, I checked it, it is unsafe, I know, etc. And for example, if you want to have a shell command, you will have to write this is unsafe, I know it, and I want to change it, but I know that will lead to a stable state and not to something that will change all the time. And iteration, of course, something that we currently don't handle very properly in Rudder. We want to have explicit iteration, because nowadays we only have implicit iteration, which is a bit complicated for people to understand and for the system to handle. And one last thing, I think it's the last one, I would like to add in the language is include the templating language into the base language to be able to detect if the template is properly applied and if the template has the right syntax and if it uses variables that are really defined or not. So we can detect at compile time on the server before going to the agent that your template is valid and will be applied correctly. Okay. Any question? Yeah?
The compiler is in the server, not the agent, right?
Currently, we intend to have the compiler on the server because we want to be able to target any kind of node. So only the server is sure to have everything to run Rust code. But I think on the long term, our idea is to put the compiler on the agent whenever possible, and leave one on the server when it is not possible. For example, we currently target AIX, and we cannot use Rust on AIX currently, so we cannot have the compiler on the agent. So it will, for some time, be necessary to have the compiler on the server. And anyway, we'll always have a compiler on the server because we want to be able to check things on the server before sending to the agent, even if not necessarily transforming data on the server.
Yeah, because as the agent needs to be the slightest possible to affect less possible the system.
Yes.
Computing something on it seems
yes, it will depend on the agent and the kind of agent, and because one other thing is that if you compile on the agent, it will be less CPU intensive on the server. So it's a kind of a choice. So I think on the long term we may want to be able to choose where we want to put it.
The problem is if you have a couple of thousand systems, then your central root server doesn't scale, so you can't throw unlimited root servers.
yes, it's a X problem.
I think it's an optimization problem. You choose. Yeah. Okay. Thank you.